Welcome back to the micromodule series, Understanding Bias in Epidemiological Studies. In this module, we will be focusing on another method for controlling confounding, which is standardization. The objectives of this module are to explain how standardization can help control for confounding and explain the limitation of standardization. To understand how standardization works, let's look at an example that compares mortality rates between Sweden and Panama. From these two tables, we can see that the overall mortality rate was 9.8 per 1,000 persons in Sweden and 7.7 per 1,000 persons in Panama. We can also see that Sweden had a higher proportion of older people compared to Panama. Based on the higher overall mortality rate in Sweden, can we conclude that the living standards or quality of healthcare in Sweden was lower? Or in other words, can we say that the difference in overall mortality rate between the two countries was caused by living standards or quality of healthcare? It seems unlikely because statistics shows that the socioeconomic development of Sweden was much better than that of Panama. It is thus suspected that the different age compositions might have contributed to this difference too, as the proportion of old people who were more likely to die was much higher in Sweden. In other words, age is a potential confounder in this case. To remove the potential confounding caused by age, we may use a standard population to calculate the age-standardized mortality rate of each country. Briefly, for each country, we need to multiply the actual mortality rate in each age group with the number of people in the corresponding age group of the standard population to get the expected number of deaths in each age group. Add them up, and then divide the sum by the total number of the standard population. This process is called standardization. Suppose we use a standard population whose age composition is as shown in the rightmost column in this table. Let's do the standardization for Sweden first. In Sweden, the age-specific mortality rate is 1.1 per 1,000 persons for people age 0 to 29, 3.6 per 1,000 persons for those age 30 to 59, and 45.7 per 1,000 persons for those age 60 and above. We multiply the age-specific mortality rate in each group with a number of people in the corresponding age group of the standard population and add them up to get the expected number of deaths. Then, divide the sum by the total number of the standard population. The age-standardized mortality rate in Sweden calculated in this way is 6.8 per 1,000 persons. Similarly, we can calculate the age-standardized mortality rate for Panama, which is 10.2 per 1,000 persons. As calculations of age-standardized mortality rates are based on the same standard population, there is no longer imbalance in age composition between the two countries. Thus, comparison of the two age-standardized mortality rates is free from the potential confounding caused by age and can help draw a fairer conclusion about the relative living standards or quality of healthcare in the two countries. It is important to note that the age-standardized mortality rate is not the actual mortality rate. Instead, it is calculated for purposes of fair comparison. The standard population could be an existing actual population, such as the United States population in 1999, or a created hypothetical population, such as the two countries' populations combined. The absolute number of people in each age group does not matter, because mathematically all of them will be canceled out in the calculation. What really matters is that calculations for the two countries are based on the same population, so that the age composition or percentage of each age group is the same. Apart from age, other factors such as sex can be standardized too, if deemed necessary. The total number of calculations needed to be performed in standardization is equal to the levels of factor 1 times the levels of factor 2 and so on, and then multiplied by the number of populations. Thus, it would be not practical when there are more than a few factors to be standardized. In the above example, there are 3 age groups in each population and 2 populations in total. Thus, we need to calculate a total of 6 age-specific rates. If both age and sex are standardized, then the above calculations will need to be done in male and female separately, leading to a total of 12 age-specific rates. In epidemiological studies, typically a number of potential confounders need to be controlled for, so standardization would require performing a huge number of calculations one by one, which is not practical. Okay, in this module, we discussed how standardization can help control for confounding and the limitation of this method. In the next module, we will talk about the use of multivariable regression analysis for controlling confounding. Thank you for listening.